All right. So I'll give that last person that just came in a second. So just a review in the chat. There's some information for you. The Kahoot is linked, and then how to get to the Kahoot, the www.kahoot.it. Put in this game code. You should be on here. I think we're only missing like a few of you. So there's 100 questions on the midterm. It's due March 18th, not March 8th. That's my bad. That was yesterday. There's 100 questions. They're all multiple choice, drop down, all that. There's no actually free response or anything you have to write. You don't have a time limit, but you only get one attempt, and you have to do it in one sitting. So if you exit the browser, it will submit the exam for you. So make sure you don't do that. I think that's pretty much it for the exam. So most of the questions that are on this Kahoot are on the exam. So as long as you feel good and mastered these questions, you should be good. All right, so I'll go ahead and get it started. Those of you coming in late, you can join. There's usually a code down at the bottom. All right. Theories and laws have been proven 100% correct. So if you've never played this before, it'll give you true or false, and you just select red or blue on your screen. There it is. And anybody coming in right now, the game pin is at the bottom right of the screen. You just go to www.kahoot.it and put in your game pin. All right, false. Theories and laws are not proven 100%. They are revised as we find more information. All right, if you've never played this before, it'll give you a leaderboard so you kind of know where you stand. All right, number 2, all maps show elevation. True or false? False. Not all maps show elevation. Excuse me. All topographic maps show elevation, but not all maps show elevation. So like the Google Maps on your phone, that doesn't necessarily show elevation, right? So this would be false. All right. Alfred Wegener founded plate tectonics. True or false? That would be false. Alfred Wegener founded Continental Drift. It was him, Harry Hess, and Arthur Holmes that founded plate tectonics totally. So they all had their individual theories that equaled plate tectonics. Okay, so he is Continental Drift. Convergent plate boundaries are generated from tensional stress. Convergent plate boundaries are formed from tensional stress. False. Convergent plate boundaries are pushing together. So this is compressional stresses at convergent plate boundaries. Tensional stress comes in with divergent plate boundaries. So the pull apart is diverging. That's divergent. So this would be false. A raised relief map is a 3D representation of topography scaled down. True or false? True. So a raised relief map, unfortunately, because we're online, we didn't get to touch them, but they're basically like little 3D models of what a topographic map would be, and you can run your hands over it and feel the mountains and the valleys. So this is true. All right, the verbal scale on a map is depicted by a bar and distance relationships. The verbal scale on a map is the bar and distance relationships. False. So the verbal scale was the scale that says 1 inch on the map is 100 feet in the real world. So that is the verbal scale. It's a verbal representation of what the scale of the map is. The scale on the bottom with the distances, that is your bar scale. Okay, so this is false. The inner core is liquid. True or false? The inner core is liquid. False. The inner core is solid. The outer core is liquid. So the crust is solid. Get down into the mantle where it's molten. Then we get to the outer core, which is liquid, and then the inner core is solid because the pressure is too great at the interior of the Earth that nothing can move. So the inner core is solid. All right, the largest plate on Earth is the Pacific plate. True, the largest plate on Earth is the Pacific plate. Good. New crust is created at transform plate boundaries. At transform plate boundaries, new crust is created. True or false? That would be false. New crust is created at divergent plate boundaries. So remember, at divergent plate boundaries, material from the mantle can come up and actually form new crust where those two plates are pulling apart. At transform plate boundaries, all they do is slide past each other. So all they do is create little crumbled mountains in between and horizontal offset on the surface. Okay, so new crust is created at divergent plate boundaries. Observation is the first step in the scientific method. True or false? Observation is the first step in the scientific method. That would be true. So a lot of people think hypothesis is the first step, but that comes after you've made some observation that there's a problem to solve, right? So the observation is the first step. Blank stress is associated with divergent plate boundaries. So here we get into some more options. So red is shear, blue is compression, yellowish is tension, and green is all the above. So is it shear, compression, tension, or all of the above? It's tension. So remember, divergent plate boundaries pull apart. That is tension. Pushing together at convergent plate boundaries is compression, and sliding past one another at transform plate boundaries is shear. Okay, so here we're pulling apart, so this is tension. As a rift in the Earth's crust forms, what feature commonly follows? So a rift meaning a low point. So when things start to pull apart and there's a rift, what do you see? Okay, it's a mid-ocean ridge. So accretionary wedge is associated with the subducting slab. The trench is associated with that as well, because that's where in an oceanic collision, there's a big deep trench, like the Mariana Trench, between the two plates coming together. And then a melange is basically what we call an accretionary wedge that has been scraped off the downgoing plate and then pushed onto land. And then it's kind of this mismatch. Melange is a French word for basically a conglomerate or a bunch of different types of rock. Okay, so when we're rifting, we're pulling apart. So eventually that pull apart will become either an inland sea, but that's not an option here. So the closest thing is a mid-ocean ridge, which is where new crust can form between those two diverging plates. All right, blank stress is associated with convergent plate boundaries. Is it shear, compression, tension, or all of the above? Good, compression. Okay, so remember, convergent plate boundaries, we're compressing. Where on Earth is the best example of current active rifting? So would that be in Central Australia, East Africa, Japan, or the Mariana Trench? Where did we talk about rifting occurring? Good, that would be East Africa. So the East African Rift, I'm sure you've heard of it. I've talked about it in my lectures. That's where two plates are pulling apart and they are rifting and creating the inland sea. So I talked about the Red Sea. That would not be there if the East African Rift wasn't actually rifting. We're actually pulling apart. Okay. Blank stress is associated with transform plate boundaries. Is that shear, compression, tension, or all of the above? That will be shear. Good. All right. Blank was the how in developing the theory of plate tectonics. So which of these four things, magnetic field, paleomagnetism, mantle convection, or continental crust, explain the how in the theory of plate tectonics? So basically, how does plate tectonics work? Okay, this is mantle convection. So paleomagnetism supported the theory, but paleomagnetism isn't how. Paleomagnetism is the way that rocks will align themselves to magnetic north when they are formed. Okay, so it helps us prove plate tectonics, but is not how the plates actually move. So the way the plates actually move is mantle convection. And if you remember, convection is the cycling within like a boiling pot of water, heat transfer method. Now with lava or magma, in the mantle, that also occurs. And if they are two convective cells that pull away from each other, they will tear basically the crust apart, and that forms a plate boundary. So two plates are being pulled apart. Yes, I'm recording it. Sorry, it was flashing at me. Yes, I will post it on YouTube and then post it on Canvas for you. All right, what theory proved that the continents were not fixed? So here we're just talking about the continents not being fixed. Yes, so if you need to leave at any time, feel free, that's okay. You can hop in and out if you have other classes or work or a kid screaming. Mine's being good, she's on her switch right now. Okay, good, so continental drift, hence the word continent, right? So the continental drift was the theory that the continents were not fixed, not necessarily the oceans or that there were plates. This is just looking at the continents were not fixed. So that's continental drift. Blank is the theory that the oceanic crust is splitting apart due to what? So what is the theory that suggests that the seafloor is pulling apart? Oceanic crust is being pulled apart.
I have a question. It's kind of off topic, if not. So,
Okay.
like, how do like these people come down to this? Like, how do they think about, oh yeah, let me go study the ocean, or let me come up with like all these words and everything? Like, how did that come about?
Usually what happens with a lot of these things is people, especially before we had computers and things, were pretty bored. So they made a lot more observations in the natural world that maybe, us today don't necessarily recognize as issues. And when they did that, they started developing, well, why would it be like that? I mean, you probably do that in your everyday life too. You just don't realize it. And it's not necessarily as big of a problem as these are. I'm an understanding science. But most of this stuff didn't come about. It wasn't really well developed and understood until about in the 1960s. So technically, of all of the science, this was kind of one of the last things. Geology was, even though geology was the first thing, it was sort of the last thing to, I don't want to say discovered, but to be formulated into theories. So a lot of our science is newer than, let's say, physics or chemistry. But usually it starts with somebody just making an observation. So we talked about Alfred Wegener. He started looking at the continent's shapes, and he went to places like Greenland and the Galapagos, and he started making observations about, the different creatures there and why were some in both places. How did they get there if they didn't have ships? So it just kind of starts that way, and then it snowballs. As far as the terms, I mean, seafloor spreading is pretty, that makes sense, right? The sea
Yeah, not just
is
that, but
spreading.
like to come up with like continent names too, or like even like the words like the paleomagnetism, like how do they come up with that? And like how do they get to decide, oh yeah, this is what this is?
So magnetism obviously has to do with magnets, right? So the study of paleomagnetism is the study of old magnets, essentially. So paleo means before. So anything that's essentially older than what you would consider historical. So historical is anything in the last 1,000 years or so. So anything before that, formed before it, is considered paleo. So sometimes I'll talk about like paleo channels. So instead of a regular like river channel, it's a paleo channel. So it's an old river channel that's no longer in use, or water's not flowing through it anymore. So with paleomagnetism, it is old magnetic information basically from the way the Earth's magnetic field used to be. So that's kind of how they get those terms. So they kind of make sense, even though they're not necessarily layman terms. They don't just kind of go, I'm going to name this after myself. Although that's what a lot of people that try to conquer things do, right? So like continental drift, that kind of makes sense because the continents are drifting. So that's kind of where a lot of the names come from.
It's more like, who decided that continents were going to be called continents? Like, why are they called continents?
I don't actually know that, but I don't know where all of those words come from. But as far as the geology terms, I can tell you most of them. And then some people will try to name stuff after themselves. The plates are mostly named after geographical locations. So like the Pacific plate is over most of the Pacific Ocean. The North American plate is over North America. And then other relevant names nearby will also contribute to why things are called something. So that's kind of a little bit of information on that, but yeah. All right, what are the different types of crust? This one's pretty straightforward. All right, continental and oceanic, those are the types of crust. Good. I'm trying to move a little bit through here so we can get through the questions. What is the composition of the continental crust? Is it made up of gneiss, basalt, granite, or pegmatite? That would be granite. Good. All right, what is the composition of the oceanic crust? Good, so this one's basalt. So most of the continental crust is granite and most of the oceanic crust is basalt. What makes continental plates different from oceanic plates? So continental plates have more volcanoes. Oceanic plates are older. Continental plates can flow internally, or oceanic plates are more dense. Good. So the oceanic plates are more dense. That's the big difference between continental plates and oceanic plates, is their density. Which layer of the Earth can move internally or flow? So think about which layer would have the ability to flow. Good, that would be the outer core. Remember, in order to flow, it has to be liquid. So the only layer that's actually liquid is the outer core. Plates at a transform boundary move underneath each other, side to side, on top of each other, or apart. Good, side to side. Remember, transform plate boundaries move like this, side to side. Which of the following features is associated with oceanic convergent plate boundaries? Remember, oceanic plate boundaries. Is that a volcano? Geez. Volcanic island arc, a mid-ocean ridge, high mountains, or a rift valley? Volcanic island arcs. Remember, mid-ocean ridge is where two plates are pulling apart. Okay, so that's at a divergent plate boundary. But when you have two oceanic plates converging, you get volcanoes that form islands, like the Aleutian Islands. What famous transform fault is known for being a boundary between the Pacific plate and the North American plate? That'd be the Garlock, the Denali, the Alpine, or the San Andreas fault. Good. It's in our state. You should know it. San Andreas fault. What is a contour line? Is it exact elevation, lines that connect areas of the same elevation, lines that dictate the location of streams, or none of the above? Good. Lines that connect areas of the same elevation. Lines that dictate the location of streams are usually blue, but they're not contour lines. And the exact elevation are the benchmarks. What is a contour interval? Is it the difference between contour lines, the difference in slope, or the interval between elevation measurements? Interval of time between elevation measurements, or none of the above? Good, the difference between contour lines. It's contour interval. What makes transform boundaries different than other boundaries? Transform makes more mountains. Transform has almost no volcanoes. Transform is older, or transform has fewer earthquakes. Has almost no volcanoes, right? So I mentioned volcanoes with every other convergent, or sorry, plate boundary, except for transform. They have earthquakes, they make mountains, but they're not necessarily older or have more mountains. So they have almost no volcanoes. When India collided with Eurasia, what did it produce? The Appalachian Mountains, the Himalaya Mountains, the Alpine Mountains, or India did not collide with Eurasia? That would be the Himalaya Mountains. Good. At which of the following locations is the youngest rocks? On the continents, the ocean basin, the Oceanic Ridge, or the continental shelf? Where can you find the youngest rocks? The Oceanic Ridge. Remember, the Oceanic Ridge is where the two diverging plates are pulling apart, and new material is being formed there. So the new crust is at the Oceanic Ridge. Once it gets to the continents or the continental shelf, it's much older. So the youngest rocks are going to be at the ridge. The lines that are bold and darker and has the elevation indicated on a topographic map are called contour lines, index contour lines, roads, or waves. These would be our index contour lines. So if there are lines on a map and there are few of them that are bold and dark and sometimes have the actual elevation listed on them, those are the index contour lines. They're usually every fifth line or so on a topographic map. What does a scale of 1 to 24,000 on a map indicate? 1 unit on the map is 24,000 units in the real world. The map represents the entire Earth. 1 inch on the map is 24,000 feet in the real world, or 1 mile on the map is 24,000 inches in the real world. Good. So the ratio scale, which is the 1 to 24,000, is a unitless relationship, but it's unit to unit. Okay, so if you say 1 unit on the map is 24,000 units in the real world, that could be 1 inch on the map is 24,000 inches, or 1 foot on the map is 24,000 feet. It has to be the same unit. So it's a unit to unit relationship. What plate is being subducted beneath Western South America? Is that the Pacific Plate, the South Atlantic Plate, the Juan de Fuca Plate, or the Nazca Plate? Good, the Nazca Plate. The Hawaiian Islands formed at a blank. Convergent boundary, divergent boundary, transform boundary, or none of the above. It'll be none of the above. The Hawaiian Islands formed at a hot spot in the middle of a plate. So they're in the middle of the Pacific plate, and they are formed from a hot spot that's stationary, and the plates move, or the plate moves, and it preserves the islands on top of the plate. So this is none of the above. It's formed from a hot spot. What is the name of the zone of earthquakes on the top of the subducting tectonic plate? So in a subduction zone, what do we call the zone of earthquakes? Do we call it the subduction zone? Do we call it the Benioff zone, paleomagnetism, or the spreading center? It'll be the Benioff zone. So the zone where the two plates are colliding and one is subducting or going underneath the other, that is called the subduction zone. But the zone of earthquakes on top of the slab that is subducting, on top of the tectonic plate that's subducting, that zone of earthquakes is the Benioff zone. At which plate boundary does new crust form? Transform, divergent, convergent, or oceanic convergent? Where does new crust form? Good, divergent plate boundaries. Remember, two plates are pulling apart. Mantle material can fill in that gap and form new crust. Mount St. Helens erupted in 1980, causing a lateral blast. True or false? True or false? True, good. Mount St. Helens last erupted in 1980, causing a lateral blast. A Horstengraben is a series of normal faults creating mountains and valleys. True or false? Good, true. So a Horstengraben is really just two fancy terms for mountains and valleys. And it's formed from the normal faults. I can't really do that with my hands, but normal faults that alternate being angled towards each other and away from each other and can cause those down drop blocks or those blocks that are lifted up, which would be the mountains and the valleys. Okay, so this is true. An ionic bond occurs when one atom shares the 8th outer electron with another atom. So is ionic bonding sharing? True or false? False. Covalent bonding is when the 8th outer electron is shared. It makes it a stronger bond. Ionic bond gives an electron away. Seismic waves will move through granite faster than unconsolidated sand. True or false? Seismic waves can move faster. That would be true. They can move faster through, I think that says bedrock. I can't read it. Seismic waves move faster through bedrock or like granite than unconsolidated sand, which slows it down because there's too many spaces between particles. Earthquakes kill people. True or false? Earthquakes kill people. That would be false. Falling objects kill people. The earthquake doesn't necessarily kill people directly. If you're standing in the middle of a field during an earthquake, you're just going to fall down. Tsunamis are an indirect result of fault motion. True or false? Tsunamis are an indirect result of fault motion. That would be true. Tsunamis are an indirect result of fault motion. What processes form an igneous rock? What processes form an igneous rock? Do they melt, cool, and solidify? Is it melt, foliation, cool, and solidify? Is it heat and pressure, or none of the above? Good. Igneous rocks melt, cool, and solidify. The reason the melt, foliation, cool, and solidify is not the correct answer is because foliation is a metamorphic term. That's when the minerals align themselves parallel to each other. We haven't gotten there yet. And heat and pressure forms metamorphic rocks. Clastic sedimentary rocks are primarily classified on the basis of what? Grain size, degree of sorting, angularity, or mineral composition. So when you're looking at sedimentary rocks, what's the first thing that you notice? Good, grain size. Sedimentary rocks do not have minerals in them unless they are from older rocks. Remember, sedimentary rocks are made up of weathered and eroded metamorphic rocks, igneous rocks, and other sedimentary rocks. The majority of the rocks found at the Earth's surface are sedimentary, volcanic, plutonic, or metamorphic. Most of the rocks on the Earth's surface are what type of rock? Good, those are sedimentary. Compaction and cementation of grains occurs during which process? So compaction and cementation occurs during erosion, during lithification, during transport, or during deposition. Basically, what is the term that encompasses both compaction and cementation of the sediment grains? Good, that's lithification. So lithification is just a big term that encompasses compaction and cementation of the grains. Which type of weathering process is happening to materials when they rust? So when a rock is rusting, is it going through hydrolysis, hydration, oxidation, or dissolution? Good, oxidation. Blank volcanoes produce blank. So shield volcanoes produce basalt. Composite volcanoes produce granite. Caldera volcanoes produce basalt. Or plutons produce rhyolite. Shield volcanoes produce basalt. Composite volcanoes can produce andesite, and calderas produce rhyolite. Plutons can produce granite. Okay, so shield produces basalt. Which national park is home to a large volcanic caldera? That'd be Acadia, Carlsbad Caverns, Great Smoky Mountains, or Yellowstone. Good, Yellowstone. The Hawaiian Island chain is an example of a island volcanic arc, continental volcanic arc, hotspot island chain, or stratovolcanic assembly. Good, that would be a hotspot island chain. I'm glad to hear that, Valentino. What is the characteristic used to identify igneous rocks? Is it origin, cooling rate, maturity, or texture? It's the first thing we use to identify igneous rocks. Texture, good. So the first thing you always look for, is it coarse grained, fine grained, glassy? What's the texture? Good. What are the two types of Hawaiian lava? Is it papa and o'o? Is it a'a and pahoihoi? Is it papa and pohoihoi? Is it a'a and o'o? Oh, you can do this. Yes, a'a and pahoho, or pahoihoi. Good. Viscosity is controlled by blank and blank. Is controlled by iron and gas in the lava, silica and gas in the lava, oxygen and eruption style, or sulfur and eruption style. Good, silica and gas in the lava. The holes in a vesicular igneous rock like pumice are likely from what? Is this from the silica? Is this from the gas in the lava, the crystals that dissolved, or minerals that never crystallized? The holes in a vesicular rock like pumice. Where did the holes come from? Good, there'll be gas in the lava. All right, individual layers in sedimentary rocks are called what? Graded beds, cross beds, ripples, or just beds? So individual layers in sedimentary rocks are called what? That would be just beds. Okay, ripples are the waves that are produced in the rock. Chemical and biochemical rocks are classified primarily on the basis of what? Grain size, degree of sorting, mineral composition, or angularity. So here we're looking at the chemical and biochemical sedimentary rocks. Good, mineral composition. Grains become rounded primarily during which process? Weathering at the outcrop, transportation, erosion, or deposition? Where does rounding occur? Transportation. So as it's tumbling down the mountain, it loses a little bit and gets a little bit more rounded. So weathering out the outcrop a little bit. But as it's transporting from its source location to its depositional area, that's when most of the rounding occurs. All right, which transport medium carries the largest particles? Which carries the largest particles? Is that ice, water, wind, or all of the above? That will be ice. So ice being glaciers. Glaciers can move the largest particles. It is unusual for blank to carry grains larger than sand. Would that be ice, water, wind, or gravity? What can't carry anything larger than sand? That would be wind. Good. Okay, so we have about 40 more and 2 minutes left. I'm going to keep going. So if you need to hop off for another class or work or anything, feel free, but I'm going to keep going so that this is a full recording. Okay? But you can stay on if you'd like. What is the relationship between texture and cooling rate? Larger grains equals slower cooling. Larger grains equals faster cooling. Smaller grains equal slower cooling, or none of the above. So which relationship is true? Good. Larger grains is slower cooling. The smaller grains is faster cooling. An igneous rock with a coarse grained texture would likely have formed from a volcano, from a pluton, from subduction, or none of the above. From a pluton. So remember, coarse-grained rocks come from plutons, and fine grain comes from volcanoes. Ripples, dunes, and cross bedding are sedimentary structures that can be used to help determine what? So all of the sedimentary structures can help determine what? Wind direction, current direction, past environments, or all of the above. Good, that'll be all of the above. All of those are true. Graded beds tell a geologist that turbidity current deposited these beds, depositing finer material first. Turbidity current deposited these beds, depositing coarser material first. Or a slurry deposited these beds with little sorting. Or density current deposited these beds, depositing finer material first. I know it's a lot to read. You won't have 30 seconds on the test. Good. Turbidity currents deposited these beds in graded bedding, and they deposit the coarser material first because of gravity, right? So gravity pulls down the coarser material first, and then it goes fine upward. All right, blank controls maturity. Does rounding control maturity, sorting, grain size, or all of the above? Good, that'd be all of the above. What happens to the pore space in rocks when the grains become more compacted? Does the pore space increase, decrease, stay the same, or none of the above? So what happens to the pore space when compaction increases? Does the pore space get smaller, bigger, or stay the same? Good, it decreases. So pore space gets smaller and smaller the more compacted it becomes. What do ripple marks say about past environments? Do ripple marks show the direction of flow, that it was a desert environment, the ease of flow, or none of the above? Good, it's the direction of flow. Which type of rock is derived from the highest viscosity lava? Will that be rhyolite, basalt, granite, or andesite? So the highest viscosity lava. Good, so that will be rhyolite. And yes, I'm gonna post this to YouTube and then I'll link it to Canvas for you guys. All right, why do Hawaiian volcanoes have broad, gentle slopes while Mount St. Helens has narrow, steep slopes? The Hawaiian volcanoes have a lower viscosity. The Hawaiian volcanoes have a higher viscosity. Mount St. Helens has a lower viscosity, or none of the above. Good, the Hawaiian volcanoes have a lower viscosity. Okay, the higher viscosity would be Mount St. Helens. Which of the following is not a texture of an igneous rock? Pyroclastic, glassy, waxy, vesicular. Which of those terms is not a texture of an igneous rock? Good, that would be waxy. Pyroclastic, glassy, and vesicular are all igneous rock texture terms. Blank volcano has the highest viscosity with a blank eruptive style. So which one has the highest viscosity? Would that be a shield, a composite, a strato, or a caldera? That'd be a caldera. Calderas are the most catastrophic eruption style with the highest viscosity. A sandstone containing T-Rex bones would likely have been formed in the deep marine, in the shallow marine, terrestrial, or lake bed. That'd be terrestrial, on land, right? T-Rex lived on land, not in a lake or in the marine environment. What type of magma has the highest silica content? Would that be felsic, mafic, ultramafic, or intermediate? So the highest silica content. Good, that's felsic. Felsic has the highest silica. Mafic has the lowest. A well-sorted sandstone with asymmetrical ripples was most likely deposited as sand by a, so if it's well-sorted sandstone with asymmetrical ripples, so one-sided ripple marks, is that a river, a glacier, a beach, or an alluvial fan? That'll be a river. So a beach has the oscillating current back and forth, and that creates a symmetrical ripple on either side. But a river flows one direction, so you'll see asymmetrical ripples. What controls ground shaking in an earthquake? Would that be the proximity to the epicenter, the energy released, the subsurface geology, or all of the above? Good, all of the above. Blank deformation causes folds and blank deformation causes faults. So what kind of deformation causes folds versus what kind of deformation causes faults? Brittle causes folds and ductile causes faults. Ductile causes folds and brittle causes faults. Or driddle causes folds and ductile causes faults. Or buctile causes folds and brittle causes faults. Kind of hard to say some of those words. It's ductile and brittle. So ductile deformation causes folds and brittle causes faults. You can remember it, brittle, peanut brittle, breaking, peanut brittle breaks, faults break. Which mineral property refers to the way light reflects off of a mineral? Is that double refraction, liquefaction, luster, or cleavage? The way light reflects off of a mineral. Good, that's luster. All right, what is the difference between cleavage and fracture? Cleavage is breaking along planes of weakness, and fracture is random breaking. Fracture is breaking along planes of weakness. Cleavage is only found in the silicate minerals or none of the above. Good. Cleavage is breaking along planes of weakness, and fracture is random breaking. P wave is blank type of motion, and S wave is a blank type of motion. So is a P wave shear and an S wave compressional? Or is a P wave compressional and an S wave shear? Is a P wave shear and an S wave tension? Or is a P wave tension and an S wave shear? So a P wave is a compressional and an S wave is shear. Looks like most of you just kind of have that backwards. So just remember that the S wave not only stands for secondary, but you can remember it as the shear wave. And then the P wave is the compressional. All right, what are the surface waves? What do we call them? Are they primary and secondary? Secondary and shear and primary, or love and Rayleigh? So these are the surface waves. Okay, those are the love and Rayleigh waves. The primary and secondary waves are body waves. Those are inside the earth. And they produce, the combination of those two produce the love and Rayleigh waves on the surface. What controls streak color in a mineral? Is it the amount of silica in a mineral, the bonds in a mineral, the elements present in a mineral, or the way the light hits the mineral? What controls the streak color? Good, the elements present in the mineral. What is the least useful mineral property? Would that be luster, cleavage, hardness, or color? Good, color. Color tells us hardly anything. All right, what is crystal form? The way the mineral forms or grows, the way the mineral breaks, the way light reflects off the mineral, or the robustness of the mineral to other substances. Crystal form. Good, it's the way the mineral forms or grows, hence the term crystal form. A blank fault is caused by tension. A blank fault is caused by compression. So is a normal fault caused by tension and a reverse fault caused by compression? Is it reverse is tension and normal is compression? Or is a left lateral fault caused by tension and a right lateral fault caused by compression? Or is it a normal fault is caused by tension and a left lateral fault is caused by compression? Good, so normal fault is caused by tension and a reverse fault is caused by compression. Blank faults are caused from shear stress. Would that be normal, reverse, strike slip, or a combination of the two? Good, that would be strike slip. What are two major faults in California? San Andreas, Garlock, the Sierra Madre and San Andreas, or A and B? A and B is red and blue. So the green answer is if you say the San Andreas and the Garlock. Good, that would be the San Andreas and the Garlock faults. What type of fault is the San Andreas? Is it right lateral, left lateral, normal, or reverse? It is a right lateral strike slip fault. Okay, San Andreas is right lateral, not left lateral. All right, what do we use to record the waves of an earthquake? Do we use a magnetic declinator, a compass, a seismogram, or an iPhone? Good, that'd be a seismogram. What is the relationship between plate boundaries and earthquake size? The largest earthquakes are at divergent plate boundaries. The smallest earthquakes are at divergent plate boundaries, or the largest earthquakes are at transform plate boundaries, or all of the above are true. Good, the smallest earthquakes are divergent plate boundaries. Most of the largest are at convergent plate boundaries. Where is the highest earthquake hazard in the United States? Would that be Alaska and Hawaii, California, Colorado, or Canada? Be Alaska and Hawaii. A lot of people think it's California, but Alaska and Hawaii move and shake a lot more in California. Where is the highest earthquake hazard in California? Is that Fresno, Yosemite, LA, or San Francisco? Good, that would be LA. Oh, looks like most of you picked San Francisco. San Francisco has moved a lot more, but the hazard right now is in LA because the fault is locked. So as soon as that fault slips, the earthquake is going to be significant. All right, why are the highest recorded earthquakes found near subduction zones? The origin of the earthquakes are deeper, the origin of the earthquakes are shallower, the origin of the earthquakes are all the same, or none of the above. All right, good. The origin of the earthquakes are deeper at subduction zones, so the earthquakes are stronger. All right, when dip-slip faults rupture, what is the evidence we see in the field? Remember, dip-slip faults are the normal and reverse faults. Do we see horizontal offset, vertical offset, striations, or tsunamis? What would you see from a dip-slip fault? Good. Vertical offset is created from dip-slip faults. When strike-slip faults rupture, what evidence do we see in the field? Would that be tsunamis, vertical offset, horizontal offset, or striations? Good, there'd be horizontal offset. Strike-slip faults produce horizontal offset. What are the criteria for a mineral? Naturally occurring and inorganic, solid, crystalline structure, and a definite chemical composition, or all of the above? All of the above. It has to be naturally occurring, inorganic, solid, with a crystalline structure and a definite chemical composition. What are the most abundant elements in the Earth's crust? Iron and oxygen, silica and carbon, silica and oxygen, or beryllium and oxygen? Okay, that would be silica and oxygen are the most abundant in the Earth's crust. Silica and oxygen are the two primary elements that make up quartz, and quartz is the most common mineral. What is the hardness scale? A measure of the robustness of the mineral, the way the mineral breaks, the way a mineral grows, or the way light reflects off of a mineral. What is the hardness scale? Good, it's a measure of the robustness of a mineral. What is the lag time? The difference in interval times of the P and S waves, the difference in arrival times of the surface waves, the difference in amplitude during an earthquake, or all of the above? Good, the difference in arrival times between the P and the S waves. How long, or how does lag time change further from the epicenter? So further from the epicenter, does the lag time increase, decrease, stay the same, or increase rapidly and then decrease? Good, it increases the further you are from the epicenter. All right, last question. What is liquefaction? Waves of energy. Saturated soil loses strength and stiffness in an earthquake. Tidal wave is a series of waves in a water body. Or any ground shaking in bedrock. All right, that's when saturated soil loses strength and stiffness in an earthquake. Good. All right, so I'll give you your stats. So, does anybody have any questions about any of the material right now? Like I said, I'm recording this, so I will post it on YouTube. It'll probably take a little bit. And then I'll link it on Canvas, so you'll have access to this recording, and you can play the Kahoot, like I said, as many times as you want until you're sick of it. Well, if nobody has any questions, then you can feel free to sign off, and I'll stop the recording, and then I will maybe see you guys in an office hour. If you have questions, you can always chime in. You can jump on an office hour, or you can send me an email or anything like that.
Thank you.
You're welcome. Thank you guys.